Hi everyone. So next we are moving to the lecture number 2. In that you need to cover in this particular video basic of AC generator and some definitions. Okay, let us discuss basic of AC generators. Okay, so in the basic of AC generators, so by look at these two diagrams, two permanent magnets placed in between the coil is placed. This coil is rotating. So whenever this coil is rotating, some EMF will be induced. How the EMF will be induced? Everything I am going to discuss now. So the basic two laws we have to generate the induced EMF. So that is a Faraday's laws of electromagnetic induction. The working principle of AC generator is a Faraday's laws of electromagnetic induction. Okay, this is the first point you need to remember. What is working principle of basic AC generator is a Faraday's laws of electromagnetic induction. What Faraday's laws we will discuss. So the first one, first law, Faraday's first law. Okay, so we'll see what is the first law. So first law, it is state that whenever conductor is placed in varying magnetic field. So very important, varying magnetic field. Varying magnetic field. And electromotive force, that is EMF. Electromotive force, EMF, is induced. Okay, this is about the Faraday's first law. See here. So by looking at this statement, these are the two magnets. Those two magnets, current magnetic flux will be passing from the north pole to south pole. Okay. Now in between you have placed the conductor. So whenever conductor plays the varying magnetic field, the EMF will be induced. Let us see, magnetic field is varying or this particular coil is rotating. So in this case, these are the two permanent magnets. Definitely the magnetic field not varying, magnetic field is a fixed. Okay, the magnetic field is a fixed. That means you need to vary, but here varying magnetic field, instead of vary the magnetic field, this conductor is rotating. For example, this conductor is rotating, variation is possible. Whenever this conductor is rotating, rate of change of flux linkage is possible. All of you following? So clear about the first law. Moving to the second law. Second law. So in the second law, whenever according to this law, it states that the induced EMF in a coil, the induced EMF in a coil is equal to the rate of change of flux linkages. Okay, this is a second law statement. From this second law, whenever the current carrying whenever conductor placed in a varying magnetic field, EMF will be induced, right? So this magnetic field is placed in this particular conductor. The rate of change of flux linkages decided the induced EMF, that is equal to E is equal to minus N di by, that is a d phi by dt. This is a formula we have, induced EMF formula. According to these two formulas, I am going to explain the induced EMF, that is what amount of induced EMF will be generated. Coming to here, one more important point. Here negative sign indicated that according to Lenz's law, very cause of its production. This negative sign, according to Lenz's law, place the negative sign. That negative sign indication that this particular induced EMF is opposes the very cause of its production. Because of the this variation only, that rotor will be rotated, conductor will be rotated. Because of conductor will be rotated, that induced EMF is induced. That induced EMF opposes this particular rotation of conductor. Okay, that is a in-depth topics that is not required for you for KVS TGT examination. This particular things is enough. But why negative sign is present? According to Lenz law. What is mean by Lenz law? It opposes the very cause of its production. So now we are moving to the induced EMF concept. Here two slip rings are present. These two slip rings are collect the current from this conductor, the coil. And then if this particular load is connected, load light, here light is glowing, right? These slip rings are placed here to collect the current from the brushes. Okay, these are the magnets. This is the coil, right? Now coming to here. So this particular conductor, this particular coil is rotating in the anti-clockwise direction, right? See here, anti-clockwise direction. Initially, see here, initially this coil is horizontally placed. Look at here, this coil is horizontally placed. So whenever this coil is horizontally placed, the theta value, the theta, for example, the theta here 0 degrees. The first case, theta is equal to 0 degrees. Whenever the coil is horizontal, whenever coil is horizontal, the rate of change of flux linkages, the rate of change of flux linkages is equal to 0. Whenever it is horizontal, look at here, any flux is linked to this particular coil? No, all the flux are inside the coil. There is no flux linkage in the coil in the side of CD as well as BA. There is no flux linkages. Whenever there is no flux linkages, what is induced EMF? Induced EMF is 0. Induced EMF is 0 volt in the first case. So second case, in the first case, that is a theta is equal to 0 degrees. In the second case, theta is a 90 degrees. That means this coil is keep on rotating in the which direction? Anti-clockwise direction. Keep it in mind. It is a anti-clockwise direction. It is rotating. The coil side AB and then CD are perpendicular to the magnetic flux. That means maximum amount of magnetic flux linked with the coil. That means that whenever second case theta is equal to 90 degrees, the rate of change of flux linkages is maximum. Okay, flux linkage is maximum. That induced EMF is equal to maximum value. Induced EMF is maximum value, right? So whenever induced EMF is maximum value, the flux linkage is also maximum. So in the two cases, the waveform will be, in the two cases, this is a T, this is the induced EMF. This is a waveform in the two cases. So initially it is 0, theta is equal to 0. Whenever theta is equal to 90, this is a induced EMF. Okay. Next you are moving to the remaining remaining cases, right? Next, in the third case, theta is equal to 180 degrees. Okay, whenever theta is equal to 180 degrees, look at here this particular diagram. Again, this particular diagram is rotating. Again, horizontal places will be appear. In this horizontal case, in the third case, here mentioned in the third case 180 degrees. This is a particular coil is horizontal, but the here D, here C, here A, here B. In the third case, 180 degrees case. Whenever in that particular case, total entire magnetic flux are 0 cutting to this particular conductor. Whenever rate of change of flux linkages is equal to 0, rate of change of flux linkages, that is a d phi by dt is equal to 0, the induced EMF is also 0 volt only. In the fourth case, theta is equal to 270 degrees. Whenever theta is equal to 270 degrees, look at here. Whenever theta is equal to 270 degrees, again this coil is rotating. In this case, you know, this is a terminal like as a D, this B terminal like as a C, here D terminal is A, this particular C terminal is a B. Okay, these are the condition whenever theta is equal to 270. Now the coils again cutting the maximum value of flux, but the current is reversed. That means the induced EMF polarity is negative, right? So in that case, the induced d phi by dt, that is a d phi by dt is a maximum, d phi by dt is a maximum, but induced EMF is a negative maximum, right? Again, the fifth case, theta is equal to 360. Again, we repeated the same case. The d phi by dt is equal to 0. The induced EMF is equal to 0 volt only. Finally, our waveform will be time induced EMF. So our waveform initially theta is equal to 0 degrees. Again, theta is equal to 90 degrees. Again, theta is equal to 180 degrees, right? And in the negative half cycle, theta is equal to 270, and then theta is equal to 360 degrees. This is the maximum value of E maximum positive. This is the maximum value of negative E maximum. Okay, so now finally we are generating the induced EMF in the AC. This is a basic AC generator. This is the induced EMF. Okay, the induced EMF finally E is equal to V maximum or E maximum sin omega t. This is the equation we have. Okay, this is about the basics of AC generator. Now we can the current direction. We can how to identify the current direction, how to identify the induced EMF in this particular AC generator. We'll look at in the Fleming's. We have two rules. We have Fleming left hand rule as well as Fleming right hand rule. I will show both Fleming left hand and Fleming right hand rule. So the Fleming right hand rule is for the generators. Everyone remember, Fleming right hand rule is for generator, Fleming left hand rule is for motor. Okay, in the examination it is important. Look at here, in the Fleming right hand rule, the thumb finger is represented the motion, and then B represented the middle finger represented the B, that is a field flux density, and the forefinger, middle finger represented the induced EMF, that is the induced current, it is represented. So this particular diagram is taken from this electrical technology organization. This is the website I am taking this particular diagram. Okay, so next one, the same website I am taking another diagram, that is a Fleming left hand rule. Similarly, in the Fleming left hand rule, it is used for the motor. The difference here, the thumb finger represented the motion of, that is a rotation of conductor, middle finger represented the magnetic lines of magnetic flux or field, and middle finger represented the direction of current. This is the different. Here induced current or induced EMF, induced current. Here direction of current, because you are not we are giving the current to the motor. Generator, it generates the current, it generates the induced EMF. Motor, it takes the supply. That is okay. Let us see next one, some definitions related to the alternating waveform. So here let me take alternating waveform first, then I will discuss the definitions. So here I will consider the two waveforms, right? In that particular waveform, alternating, here also alternating. Just now we discussed how to generate this waveform with help of the basic AC generator working principle. Now this particular generator having different magnitudes. So I will mention the quantities, right? This is a magnitude, so or amplitude, you call it as it. So amplitude, the first term, this is amplitude in between. Next one, this is a positive half cycle, negative half cycle. Okay, here call it as a time period in between time period. time period. Is it okay? We can call it as it is a one cycle, time period or one cycle. Everyone note down, every point is important. This is the alternation, that means that it is a positive half cycle, it is a alter the negative half cycle. So alternation, positive negative. So this is in terms of time period. In terms of radians, that is called as a theta radians. The radians case, this is a 0, this is a pi by 2, this is a pi, this is a 3 pi by 2, this is a 2 pi. Now, okay, this is about the waveform. Now coming to here, in this particular waveform, the first thing we need to remember, cycle. So the definition of cycle, this is the first definition. So in this particular definition, what the meaning of cycle is nothing but a one complete set of positive and negative values of alternative quantity. Is known as a cycle. Okay, see here, in this particular waveform, this is a positive half cycle, negative half cycle, together it is called as a cycle. Okay, so in this call it as a cycle. That is a definition. So in this case, one complete set of positive negative values of alternating quantity is known as a cycle. Okay, this cycle is repeated. In case of in India, the frequency is 50 Hz is nothing but these complete cycles are 50 times. That means 50 times this complete cycles are repeated within 1 second. That is nothing but a number of cycles per second. That is a frequency. So the frequency, another unit, is a number of cycles per second. Okay, that means in India 50 Hz frequency is nothing but this type of 50 cycles within 1 second. That is called as a 50 Hz meaning. Okay, clear. Next we are moving to the second part. The second definition is a time period. It is also similar definition. Look at here. The time period is nothing but so it is a time to taken to complete a positive or negative half cycle together. It is a time period. So let us write the definition of time period. It is a time taken by the alternating voltage or current. Maybe that waveform is maybe voltage a waveform or current waveform. Voltage or current to complete one cycle is nothing but a time period. So in this case, the time period is nothing but one positive half cycle, one negative half cycle. It takes, this is the time period. So to complete, how much time to complete the one cycle, that is nothing but a time period. It is represented by the T. Okay. So in this particular diagram, what is the time period here? The time period is 2 pi. In this particular diagram, the time period T is equal to 2 pi radians. This is the time period. So the time period and frequency, the relation will be time period is equal to 1 by f. Okay, this is a relation between the time and frequency. In case frequency is more, what about the time period is less? Both are inverse relation. Very, very important point. Everyone remember that. Next we are moving to the next we are moving to the third one. Third one is a frequency. So frequency is nothing but already I mentioned the number of frequency is nothing but the number of cycles per second. So the frequency is nothing but the number of cycles per second. Number of cycles per second made by alternating quantity. Alternating quantity. Okay, so alternating quantity is nothing but a frequency. So the units of frequency is hertz or number of cycles per second. So coming to here, it is a frequency is nothing but the number of cycles to complete per second is nothing but a frequency. So already mentioned the frequency relation time period is equal to 1 by f, inverse of frequency. So finally frequency f is equal to 1 by time period. This is related to the frequency. Then we are moving to the last definition, that is a amplitude. So let us see the amplitude. So fourth one, amplitude. So amplitude is nothing but the maximum value that is positive or negative of an alternating quantity is known as amplitude. Is known as a amplitude. So coming to here, the amplitude is nothing but the alternating quantity here to here. This is the positive magnitude of amplitude. Clear? Next, here to here, negative magnitude of amplitude. This is the negative magnitude of amplitude. This is the positive magnitude of amplitude. From here to here is nothing but a peak value of amplitude. So amplitude is nothing but in this particular period, this is a positive amplitude. In this particular period, it is a negative amplitude. Okay, magnitude of the particular. For example, it is a 5 volt. That is a magnitude. That is amplitude. 5 volt is a positive amplitude. It is a minus 5 volt. Is a minus 5 volt is a amplitude. What is a peak to peak amplitude is a 10 volt. Okay, this is about the definitions, basic definitions about the alternating waveforms. Thank you.